Welcome to today's lesson, Right Triangle Trigonometry. So when we look at a right triangle in relation to an angle, in this case we're calling it angle T, we have what's called the side that's opposite to it, the side that's adjacent, and then as always the side that is opposite the right angle is called the hypotenuse. Now you've probably already learned about the three trigonometric ratios, sine, cosine, and tangent, and you might have learned the helpful mnemonic SO, CA, TOA. This helps us keep them straight. So if we look at SO, that means that sine is equal to opposite over hypotenuse. Cosine, CA, is adjacent over hypotenuse, and tangent, TOA, is opposite over adjacent. So these are just the ratios of two of the sides in a right triangle. In addition to these trigonometric functions, we have what's called the reciprocal functions. And these are secant, which is hypotenuse over adjacent, cosecant, which is hypotenuse over opposite, and cotangent, which is adjacent over opposite. So the reason these are called the reciprocal functions is since sine is opposite over hypotenuse and cosecant is hypotenuse over opposite, this means that cosecant t is equal to 1 over sine of t, secant t is equal to 1 over cosine t, and cotangent t is equal to 1 over tangent of t. I try to remember what goes with what by thinking that each reciprocal pair can only have one co. So cosecant has to go with sine. It can't go with cosine or there'd be two cos. Secant has to go with cosine. Again, because if secant went with sine, there wouldn't be any cos. And then I feel like cotangent and tangent are kind of obvious because they both have tangent in their word. But again, only one co in that pair. Example 1, using the triangle shown, evaluate sine of alpha, cosine of alpha, tangent alpha, secant, cosecant, and cotangent of alpha. So we have our right triangle. We know the measures of the three sides. We know that alpha is right here. And so if we wanted to find the sine of alpha, sine is opposite over hypotenuse. Well, the opposite side is 4 and the hypotenuse is 5. The cosine of alpha is adjacent over hypotenuse. Well, the adjacent is 3 and the hypotenuse is 5. And then finally, tangent is an opposite over adjacent, which is 4/3. Now, this would be finally if we were only looking at the first three trigonometric ratios, but now we're going to do the reciprocal functions. So the reciprocal with sine is cosecant. So cosecant of alpha has to be the reciprocal of 4/5 or 5/4. The secant of alpha is 5/3 and the cotangent of alpha is 3/4. So a couple of things to remember if we have a right triangle with angles A, B, and C. This would be side A, this would be side B, and this would be side C. And we know that the relationship of the three sides of a right triangle are a squared plus b squared is equal to c squared. And we also know that the two acute angles in a right triangle have to add up to 90 degrees. Now we're going to talk about the complementary angle theorem, and it says that cofunctions of complementary angles are equal. So for example, the sine of 30 degrees is equal to the cosine of 60 degrees. Because sine and cosine are cofunctions and 30 and 60 are complementary angles. So tangent and cotangent are cofunctions, which means the tangent of 40 would equal the cotangent of 50. And secant and cosecant are cofunctions, and 30 and 60 are complementary angles. So the secant of 30 would have to equal the cosecant of 60 degrees. So example 2, if sine of t is equal to 5/12, find the cosine of pi over 2 minus t. Well, remember that pi over 2 is the same as 90 degrees. And so this is like asking for the cosine of 90 minus t. Well, t and 90 minus t are complementary angles, and sine and cosine are cofunctions. So we know that the cofunctions of complementary angles are equal, so this means that the cosine of pi over 2 minus t has to equal the sine of t, which is 5/12. Now if we wanted to, we could check this by drawing a triangle. So I'm going to draw a right triangle. I'll call this t, and the sine of t, opposite over hypotenuse, is 5/12. So I'm going to label the opposite 5 and the hypotenuse 12. Well, this angle right here has to be pi over 2 minus t. Now the cosine of this angle is the adjacent 5 over the hypotenuse 12. So that just verifies what we did by using the complementary angle theorem. Example 3, find the unknown sides of the triangle. Now we can use SOHCAHTOA to do this, but notice that one of the angles in my right triangle is a 30-degree angle, which means then that the other acute angle has got to be 60 degrees. So this is a 30, 60, 90 special right triangle. So notice that the side we've been given is the short leg. Side A is the long leg, and side C is the hypotenuse. So in a 30, 60, 90 right triangle, we know that the hypotenuse is 2 times the short leg. So that means that side C has to be 2 times 7, which is 14. And we also know that the long leg is the short leg times the square root of 3. So that means then that A would have to be equal to 7 times the square root of 3. A very common application of right triangle trigonometry is word problems that involve angle of elevation and angle of depression. And what's important to know about both of these is they're always formed with the horizontal. So an angle of elevation is this angle that's being made with the ground, and an angle of depression is an angle that's made where, say, you're looking in the horizontal direction, and then how far down do you have to look to approach what you are depressing to. But no matter what, angles of depression and elevation are always made with the horizontal. So example 4, a 200-foot tall monument is located in the distance. From a window in a building, a person determines that the angle of elevation to the top of the monument is 15 degrees and that the angle of depression to the bottom of the tower is 2 degrees. How far is the person from the monument? So let's define our variable. So we'll let x equal the distance from the monument. And I'm just going to draw this monument that we know that is 200 feet tall. And we have this building that is some distance away from the monument. We have a person looking in a window who's looking up to the top of the monument. And they say that the angle of elevation is 15 degrees. So I'm going to draw a horizontal segment, which is also x units long, and the angle of elevation has to be made with the horizontal, so this is 15 degrees. Now they also say that the angle of depression to the bottom of the tower is 2 degrees. Alright, I didn't do a very good job of drawing this to scale, but this would be the angle of depression. So we need to use SOHCAHTOA to somehow find x. The problem is that we don't know any of the sides of either of these triangles. So what I'm going to do is I'm going to call this segment right here y. Now if this whole length has to be 200 and this is y, this is going to be 200 minus y. And now I'm going to use SOHCAHTOA for the two triangles to write two equations. So let's look at this top triangle. I've labeled the opposite side and I'm looking for the adjacent side. So I can say then that the tangent of 15 degrees is 200 minus y over x. Now when I look at the other triangle, I have labeled again the opposite, and the adjacent. So I can say that the tangent of 2 degrees is equal to my opposite, which is y, over my adjacent, which is x. So technically I don't need to know what y is. I'm looking for x. So I'm going to try to manipulate these two equations so that I can solve for x using substitution. So first I'm going to say that x times the tangent of 15 is equal to 200 minus y, and x times the tangent of 2 is equal to y. And now what I'll do is I'm going to substitute this in for y in the first equation. So x times the tangent of 15 is equal to 200 minus x times the tangent of 2 degrees. I'll add this to both sides and I'll get x times the tangent of 15 plus x times the tangent of 2 is equal to 200. I'll factor out an x and I'll have the tangent of 15 plus the tangent of 2 equals 200, which then leads to x has got to be equal to 200 divided by the tangent of 15 plus the tangent of 2 degrees. And if I put this into my calculator, I get that x is approximately equal to 660.4 feet. Now since I defined x as the distance, then that means that the distance that the person is from the monument is 660.4 feet. That's all for now. Thanks for watching.